Alright, welcome to another video for my career development. This is Graham's networking lessons video. I'm using the sauna again, so if you want to, if you're interested in kind of the things I do personally, head over to my personal channel. But this channel is just devoted to core content for thriving in a career with computers. In the last video, I was working on reading RFC 9082. This is a part of my Wild Networking RFC series where I read the latest RFCs, and then I also explore some of the background knowledge required to understand them fully. My reasoning for doing this is first of all, this is the Wild Networking series, so we're focusing on things you see in the wild, either on a job or in actual technical discussions with other experts, and not just learning something because you want to pass it on a test or you want to get a good grade in school. So RFCs are the perfect thing for that. They're all public. We read the copyright usage, so there wasn't anything complicated happening there either. And not only that, if you're in the wild, you're having a technical conversation, you've got instant credibility backing up what you say, because you could just recite something from an RFC, give them the link to that, and start your conversation from a place that is kind of more grounded in credibility and expertise. So we're learning about the replacement to the Whois protocol. The Whois protocol helps people identify who maintains, operates, and owns the servers that are all interconnected to make up the internet. Whois protocol has a lot to be desired. It's a really old protocol. So this RFC was released in June of 2021, just last year. So this is a really good update here. And it describes the registration data access protocol, which is meant to replace that Whois protocol eventually. Okay, so last video I finished up 6.3.1, so we're going to start here in section, 3.1.3, so we're going to start here in section 3.1.4, name server path segment specification. So the syntax here would be name server / name server name. Name server, that's for DNS. It maps FQDNs to IP addresses. The name server name parameter represents a fully qualified host name as specified in, and then these are our background RFCs, which we'll explore into with more detail later. For now, we'll just keep them up here. So that they're ready to go if you want them later. Clicking these links just takes you to the reference section. So once we're at the reference section here, we have to click one more time to get to the actual RFC. And then the final thing I like to do is put them in order in my tabs so I can save them for later. Alright, and then click into the file format that I want to read them in. I want to read them in HTML with inline errata if possible. Alright, so now we're good to move on. Internationalized names represented in either A label or U label format. So we've got that RFC open there. Are also valid name server names. IDN processing for name server names uses the domain name processing instructions specified in section 3.1.3 and section 6.1. We already read that was the prior section, and that section we'll be reading later, for information on character encoding for the U-label format. The following URL would be used to find information for the ns1.example.1 name server. So we can see it's just tacked on the end there after the rdip/. The following URL will be used to find information for this example of a name server, and we can see these special characters are permissible, including these dots here. All right, section 3.1.5, entity path segment specification. Syntax is going to be entity slash handle. The handle parameters represents an entity, such as a contact, registrant, or registrar identifier whose syntax is specific to the registration provider. For example, for some DNRs, and DNR, I don't remember exactly what that means. I do, domain name registrar. Contact identifiers are specified in RFC. So here's a new one, and here's another new one. So we'll open those and arrange them. Okay, and this is the Extensible Envisioning Protocol, EPP, Contact Mapping, RFC, and then this is the Extensible Provisioning Protocol, which is the same thing. So this looks like it's a I wanted to say that this looked like an extension, but I'm not. I think it's just describing a different element of it, the contact mapping element. Okay, so the following URL would be used to find information for the entity associated with handle 4 capital X's. There we go. So we're going to use entity slash. Section 3.1.6, help path segment specification, syntax help. The help path segment can be used to request helpful information, command syntax, terms of service, privacy policy, rate limiting policy, supported authentication methods, supported extensions, technical support, contact etc. from an RDAP server. The response to help should provide basic information that a client needs to successfully use the service. The following URL would be used to return help information. Search path segment specification. Pattern matching semantics are described in section 4.1. And unfortunately, I can usually only go a half an hour in this thing, and I'm at that half an hour mark right now. And I don't think pushing it is smart. So I'm gonna pause the video here and kind of change things around and come back to this at the next available, most convenient part for me in the day. But this 8 minutes of content is going to remain. I'll just pause it and I'll be back soon. All right, I'm back and I'm feeling really good. So we're going to start, we're going to keep going with section 3.2, search path segment specification. Pattern matching semantics are described in section 4.1, and I think my volume's a little hot here. I'll turn that down a little bit. There we go. The resource type path segments for search are domains used to identify a domain name information search using a pattern to match a fully qualified domain name. Name servers used to identify a name server information search using a pattern to make a host name. Entities used to identify an entity information search using a pattern to match a string identifier. RDAP, Remote Database Access Protocol, I think. Let me check that. This is section 3.2. Sorry, Registration Data Access Protocol. So it's the protocol where you can look up registration data. RDAP, Registration Data Access Protocol, which will replace the Whois protocol. Search, and hopefully that happens really soon, but it might take still quite a while because this RFC is so new. RDAP search path segments are formed using a concatenation of the plural form of the object being searched for and an HTTP query string. The HTTP query string is formed using a concatenation of the question mark character. Okay. Oh, a concatenation. So there's going to be another character besides that. A noun representing the JSON object property associated with the object being searched for, and the equal sign character, and the search pattern. This is in contrast to a more generic HTTP query string that allows multiple simultaneous parameters. Search pattern query processing is described more fully in section 4. For the domain, name server, and entity objects described in this document, the plural object forms are domains, name servers, and entities. Detailed results can be retrieved using the HTTP get method and the path segments specified here. So we can see we've got the question mark on all of these examples. Now we've got differences here. We've got name, NSLDH name, and NSIP. Those are the nouns that represent the JSON object property associated with the object being searched for. So we're going to search for the domain name here. We're going to search for the name server here, and here we're going to search for the name server IP. And then the third thing that is concatenated as part of the 4 things to make our domain search addition to the URL here. First thing is the question mark. The second thing is the noun. Oh my, okay, that was really, sorry, my batteries are low. I really don't like these headphones. It just blew up in my ear because my batteries are low. So I don't know what to do about that. I guess I'll keep going. If that blows up in my ear again, though, I will not like that. So I guess I'll just turn down the volume. Okay, so I hear the clicks a little bit lower, and it looks like my audio was unchanged. Yeah, I'm not a fan of these headphones. I think they're a little bit more expensive than my other ones. So I think the Bluetooth is just a little bit trickier for Ubuntu to handle. They might be better on Windows, but all right. Anyways, so the third part of the concatenated objects is the equal sign, and then the final part is a search pattern. You can have spaces in that. You can have whatever you would like. All right, so searches for domain. So there we go. These are the domain searches. These are searches for domain information by name. They're specified using this form. So we've got a bit of a difference here. So here, instead of just a pattern, we're gonna fill in these 4 X's. So XXX is a search pattern representing a domain name in letters, digits, hyphen, LDH format, which is specified here. We've already got that open. The following URL would be used to find DNR information. So domain name registrar, I think that stands for. I'm gonna verify that though, because I got the remote registration data access protocol. I got that acronym incorrect, so I want to make sure I'm getting this one right. Yep, so it stands for domain name registries, or I think registrars. I think it's the same thing. But yeah, DNR, domain name registries, I got that more or less correct. The following URL would be used to find domain name registry information for domain names matching the example star.com pattern. IDNs in U-label format, which we have open already. Can also be used as search patterns. Searches for these names are of the form /domains question mark name equals XXX, where XXX is a, four X's, is a search pattern representing a domain name in U-label format. So it looks like both formats are described in this. It looks like U-label format is described here. I know there's another format they talked about in here. I forget what it was. So I don't know if it's described in a different RFC or if both formats are described in this RFC. See section 6.1 for information on character encoding for the U-label format. So let's actually look at that quick. I want to see if both formats are in that RFC or if it refers to another RFC for another format. Yeah, so it looks like A label is the other one, and A label is part of this RFC as well. Yeah, so there's actually three kinds of labels. There's A labels, U labels, and NR LDH labels. And we know what LDH stands for. It stands for letter dash hyphen. And we know that from here. Letters, digits, and hyphens. Those are the accepted characters. You can't use underscores. You can't use special characters besides a hyphen. LDH means letters, digits, and hyphens are accepted. Yeah, I might want to, I'll just leave this set here and leave all this highlighted because this clarifies what that U label and A label is, and we might forget what that is as we keep reading this, so we might need to come back and reference this RFC quick. Searches for domain information by name server name are specified using this form. So we got that classic question mark and then the noun and then the equal sign. There we go. Y is a search pattern representing a host name in letters, digits, hyphen. That's the LDH format in RFC 5890 that we have open here. So that format, I'm sure, is discussed somewhere else. Yeah, so here's the LDH explanation of that. But we're not too concerned about that right now. The following URL would be used to search for domains delegated to name servers matching the ns1.examplestar.com pattern. There we go. So we can see we've got our four things here. Equal sign, and then that. And then before that we have our URL. Searches for domain information by name server IP address are specified using this form. Okay. 4Z is an IPv4, okay, or an IPv6 address. So here's that lore, these lore RFCs. We have them on just about every other one. So this is one thing that can be interesting by doing this as well. By focusing on these new RFCs, these old RFCs are going to pop up again. So it's going to be a good reminder that the fundamentals and basics are really important to have a good sense of, because they'll just keep popping up again and again, and we'll keep having those fundamentals refreshed. So I think this is a really valuable thing for me to be focusing on, is these newer RFCs. Now I could, on the contrary, just devote the channel to the older RFCs, but I actually thought a lot about that, and I'd rather do the newer RFCs because they're more relevant. Somebody might be able to get more out of them. They're more exciting too, because I submitted errata on the BGP RFC from 1992, and it's like, okay, great, who's this helping? They already discussed this. Maybe it makes the problem a little bit more clear, but it makes it more clear 30 years after it would have helped it for it to be more clear. So if I can submit an errata for an RFC from last year or 2 years ago or even this year, and it helps drive the conversation forward, and it helps make that protocol and the RFC better, that's what I want. That's why I'm focusing on these newer ones. And then in doing that too, as we see, I keep getting reminded again and again and again, what are the fundamentals, what are the core concepts, and I can go back and review those as part of my videos on the newer RFCs. Okay, so let's just put these in order. All right, so I'm gonna get down here. The following URL would be used to search for domains that have been delegated to name servers that resolve this address. So you can see we've got our 4 objects here, the question mark, the noun that we're searching for in the results, and then the equal sign, and this is how we search for domains that have been delegated to name servers that process this address. Okay, so that brings me to this section. I'm going to need to take a quick break before this section. Before I do that, though, I want to get a little bit of hands-on experience with this if I can. So I'm going to Google for RDAP, and hopefully I don't get anything that would have required safe mode. I get residential drug abuse program, but that's not what I'm looking for. So let's do. So it looks like I am getting some results for registration data access protocol. So let's click on this. Oh, here we go. So here's a pilot program. Yeah, basically what I'm looking for is like a test environment or somewhere where I can actually put in these URLs. Example.com is just it's just a place. If I actually go and I put this in my browser as a URL to visit, yeah, we can see that example.com is for use in illustrative examples in documents. So you can actually test out our ADP using example.com because it doesn't resolve to a device that actually is running the RDAP, registration data access protocol. Okay, so let's type in registration data access protocol, and then we'll say testing or playground or something like that. Playground, sandbox, we'll search for that. So here we go, ResearchGate, that looks pretty good. Here we go, about.redp.org. Let's do a lab. This looks like it's good. It's a forum where they might be discussing this. Let's type in sandbox. This could be interesting. All right, and then we'll go with that. Huh. Let's try this. Yeah, that's not gonna work. Oh, here we go. There we go. So this I think is a good sandbox for this. This looks pretty interesting to me as well, but it's going to take a little bit to get going. So let's try name equals this. So we can see here. Perfect. So yeah, we should be able to do this. Or sorry, RDAP. And then wait, what was it again? Oh yeah, we should be able to do this. Okay, well, I guess it's not working like that there. Okay, so we can. I think if I just take away this RDAP like this. Okay, well, I'm not exactly sure how to use that. Okay. All right, so I think I'm gonna stop it here, and then I will come back to this after a short break. So thanks for watching, and see you after the short break. I mean, I'm at a half an hour. So I'm kind of tempted to just keep it in case I lose the video, but no, I just need a short break. I'll be back soon. Okay, welcome back after my long break. I want to try to wrap this up here, so it looks like I just got one more section before I'm on to section 4. So this is section 3.2.3, entity search. I think I already went over some of this. So the 4x's is a search pattern corresponding to the FN property of an entity, such as contact, registrant, or registrar. Name as described in section 5.1 of RFC 9083. So this is 9082, so 9083 is going to be the one we'll read next. The following URL would be used to find information for entity names matching the Bobby Joe pattern. There we go, so FN. Searches for entity information by handle are specified using this form. 4x in uppercase is a search pattern representing an entity, and we can see this 4x. It looks like it can be more than 4 digits. I'm not sure. It looks like this is just how they're choosing to describe it in the documentation here, but it's not a string that's limited to 4 digits. You can have a string with more than 4 digits. And it doesn't have to be all uppercase either. We can see we've got mixed case, and we've even got special symbols that represent the space, and another one that I believe is a wildcard symbol representing any other characters. Okay, but the 4x's is a search pattern corresponding representing an entity such as a contract registrant or registrar identifier whose syntax is specific to the registration provider. The following URL would be useful to find information for entity handles matching the CID-40* pattern. Okay, URLs must be properly encoded according to the rules of RFC 3986. In the example above, Bobby Joe star is encoded to Bobby Joe. So we can see it's got to be encoded. So this is not encoded properly. This space character doesn't work if it's in this format. It has to be this %20. So this is a difference in encoding here, and the proper encoding can't have just a space like that showing up. It has to be the space here, and this should be explained in this RFC. I might go over that later, but for now I'm just going to make sure I have that listed as part of the background RFCs to be familiar with in order to fully understand this RFC. Okay, so that's it for this video. Stay tuned for the next one where I do section 4, query processing.